The robot operating system is a set of open source software libraries and tools for building robot applications. From drivers and state-of-the-art algorithms to powerful developer tools, ROS has the open source tools you need for research, prototyping, and robot development. There's one phrase that sums up ROS. It is this: don't reinvent the wheel. Algorithms used in robotics are usually similar with slight modifications. Why do you need to write from scratch if you can just use it as a package already made by the ROS developers or its community? ROS is the fastest way to build a robot. Let's see a video about ROS from Open Robotics, the creators of ROS.
Building robots is difficult. Motors, sensors, software, and batteries must all work together seamlessly to perform a task. But there's a way to simplify the process. The Robot Operating System, or ROS, is free and open source software that defines the components, interfaces, and tools for building advanced robots. Most robots are made up of actuators, things that move, sensors, things that read the world, and control systems, or the robot's brain. ROS helps developers quickly build these components and then easily connect them using ROS tools called topics and messages. These messages can be recorded using ROS bag files or logs for easy testing, training, and quality assurance. Messages can be easily sent to a variety of visualization and teleoperation tools. With ROS, you can work with a simulated robot instead of the real thing, which some call a digital twin. This also makes testing and training easier and more effective. ROS supports hardware interfaces for many common robot components like cameras, LiDAR, and motor controllers. ROS's modular architecture allows developers to build robots free from vendor lock-in or licensing fees. ROS can also work with just about any component. Anything that has a software interface is fair game. ROS2 supports micro-ROS, a variant of ROS that runs natively on embedded microcontrollers running real-time operating systems. ROS's framework of common tools for robot development allows you to focus on addressing your problem, not on reinventing the wheel. This is why hundreds of companies, from small startups to Fortune 500 organizations, academic research labs, and government agencies, choose ROS as their robot development platform, and have downloaded over 500 million ROS packages in 2020 alone. However, ROS is more than just software. ROS is also a community of highly trained and pragmatic roboticists applying advanced robotics to every conceivable application while sharing their solutions with each other. When you choose ROS, you're tapping into a worldwide talent pool, community resources, and an ever-growing ensemble of services built on top of ROS. These services include logging and diagnostics, fleet management, deep learning data collection, testing, and quality assurance, and a whole lot more. The ROS community is now tackling every robotics market, including agriculture, factory logistics, autonomous vehicles, service robotics, food preparation, heavy industry, drones, planetary exploration, and so much more. This community is supported by the ROS Technical Steering Committee. These organizations use ROS to build better code faster, hire talented developers, and accelerate their time to market. To learn more about ROS and how it can be used to develop your robot, visit ros.org.
ROS started in 2007 with several distributions being released. Open Robotics noticed some limitations with ROS and started working on another type of ROS ground up. Hence, the first type of ROS is called ROS1, while the new one you will learn about in this course is referred to as ROS2. The latest and last ROS1, ROS Noetic, will reach its end of life by 2025, while support for ROS2 continues. Like Ubuntu operating system, Open Robotics releases long-term support and interim releases of ROS, which are usually named by the community from a list of options. In this course, you will be using one of the long-term supports called ROS2 Foxy, whose end of life is May 2023. This table shows the advantages of ROS2 over ROS1. In ROS2, continuous integration testing is not only done on Ubuntu, but has now been extended to OS X for Apple users and Windows 10 for Microsoft users. The core of ROS1 is targeting C++3 and doesn't make use of C++11 features in its API. ROS2 uses C++11 extensively and uses some parts from C++14. ROS2 improved communication over different networks using data distribution service, while ROS1 uses transmission control protocol ROS, TCP/ROS. In ROS2, other build systems can be easily supported, like Python and not just CMake. In ROS1, message and service files can have the same name, but the generated code collides. The same is the case for the request and response parts of services. In ROS2, the generated code uses separate namespaces to guarantee it's collision-free. ROS1 does not support real-time code, but relies on external framework like ROS. In ROS2, you will write real-time nodes when using a proper real-time operating system with carefully written user code. In ROS2, it is not possible to create more than one node in a process. This is due to the API itself, but also because of internal implementation decisions. In ROS2, it is possible to create multiple nodes in a process.